Assalamualaikum and good morning to one and all. Today we'll study about bioassay of serotonin, that is also called as 5-hydroxytryptamine, using rat fundus strip by 3-point bioassay. I am Sheikh Abu Sufyan. Welcome you to my YouTube channel Pharma Learning Forever. At the end of this e-learning session, you are able to discuss requirement and procedure of the experiment. Then you will be learning about the objective of this experiment, explain the receptor binding of serotonin in gastrointestinal tract, and draw DRC of serotonin and calculate unknown concentration, that is by using 3-point bioassay. So let's see what is the objective of this experiment. So in this particular experiment, we are going to determine unknown concentration of the serotonin, that is 5-hydroxytryptamine, or it is also called as 5-HT, by using 3-point bioassay. So let's see about the other aspects of this experiment. So first thing, it is about the experimental condition. So the experimental condition and the requirement of this experiment, it include first and most important thing, it is the instrument and the requirement. So the instrument, it is the student's organ bath with the thermostat, it is needed. So this is needed even in case of all type of bioassay which is related to the tissue preparation. Then aeration tube, it is needed to provide the oxygen to the tissue. Tuberculin syringe, it is needed for injecting the drug. Petri plate, beaker and the pipette are also needed for proper isolation and for storing and taking the standard amount of the drug, that is the 5-hydroxytryptamine, that is the standard, as well as the test. So this is about the instrument and the requirement of the experiment. The animal we are using here, it is the rat, and we are using here, it is the fundus strip. So fundus strip, it is the part of GI tract. So in the procedure, I will show you the which part of GI tract it is called as the fundus. So we have to isolate that fundus strip, especially from the rat GI tract. So animal use, it is the rat. Third thing, it is the drug. So we are using the standard serotonin solution, which having the concentration of 10 microgram per ml, and the test solution for which we are going to determine their unknown concentration. So we are using two type of serotonin solution. One, it is standard, which concentration it is known to you, that is 10 microgram per ml, and test solution where concentration is not known to you and you are going to determine their concentration by using 3-point bioassay. Okay. Then physiological salt solution we are using here, since we are using the rat GIT preparation. So the physiological salt solution, it is same, that is the thyroid solution. So in case of both rat ileum as well as this experiment that we are performing on the fundus strip, we are using thyroid solution only. Okay. So the PSS, it is the thyroid solution. But the most important thing is that here the contact time, it is 30 seconds. Whereas in case of rat ileum, the contact time we have used, it was of the 60 seconds. Because since the rat fundus strip, it is the very fast contracting tissue. So the contact time, that is the amount of time for which drug remains in contact with the drug, it is reduced to the greater extent. So here we can see it is reduced to the 30 second instead of the 60 second that we have seen in case of the rat ileum in earlier experiment. Okay. So the contact time, it is the 30 second. The temperature, that is the body temperature of 37 plus minus 2 degrees Celsius, it is maintained throughout the experiment. So these are the different experimental conditions that we need to keep constant throughout the experiment in order to get the good reproducible result with that particular tissue. Okay. Now let's see with the receptor binding of the serotonin and what is the principle of 3-point bioassay. So the receptor which is related to the serotonin, since we are using serotonin here, so serotonin will bind to only 5-HT receptor. So there are different types of 5-HT receptor present in the body, right, from 5-HT1, 5-HT2, 5-HT3. So out of this, all these receptors, since they are 5-HT receptor where 5-hydroxytryptamine bind to this receptor, right? So these receptors are called as serotonergic receptor. Why they are called as serotonergic receptor? Because for this receptor, the serotonin bind. It is specific to the binding site of the serotonin or binding of the serotonin. Since it is the binding site of the serotonin or it is specific to the binding of the serotonin, these receptors are called as the serotonergic receptor. So in the different tissue, when 5-HT bind to the serotonergic receptor or serotonin bind to the serotonergic receptor, it produces a different type of pharmacological action. So in final year theory, you are going to study in detail about the autocoadjutor, where you will see what is its action in the central nervous system. It means when serotonin bind to the 5-HT receptor in the brain, what action it has, right? Then when it bind to the GI tract, what action it has. So in the different tissue, when it bind, it having different pharmacological action, and it play very vital role in our body. Okay, so that you will be seeing in final year in autocoadjutor. So just for this experiment, you remember that their action on the GIT, when serotonin bind to the serotonergic receptor, it produces the contraction of the rat fundus preparation, and you are measuring that contraction of rat fundus preparation using the rat fundus, that is isolated fundus strip from the rat. Okay, so this is about the mechanism of action of the serotonin. Let's see about the principle. So in this experiment, the serotonin potency is determined by comparing its activity with that of the standard solution of the serotonin by using 3-point bioassay. Means what you are doing, first you are taking the DRC of the standard solution of the serotonin, then you are taking the dose response curve of the test solution of the serotonin, and then you compare how much is the height of the standard and how much is the height of the test by selecting 2 standard dose and 1 test dose. So the detailed procedure we'll see in the next slide. Okay, so just you remember here in this experiment what we are doing, we are comparing the potency of the standard and the test solution, and we are determining their concentration by using the concept of 3-point bioassay. So this is the principle. Let's see what are the advantage of this experiment. So the best advantage of this experiment is, since this experiment we are going to repeat the standard concentration and test concentration for 3 times, and we are going to take average of that, right? So due to that, it reduces the possibility of the error, and it is most accurate method. Whereas in case of the interpolation bioassay, in case of matching bioassay, we have seen we are not repeating the dose of the standard as well as test, and we are not taking the average of that. We are most of the time we are just taking the single dose of the standard, or 1 or 2 doses of the standard and 1 or 2 doses of the test, isn't it? Since we are not repeating it every time and we are not taking the average, there could be the possibility of the error, and it will be more clear when you complete this experiment, when you apply the formula, when you take the DRC, when you take the average. It will be more clear to you how it reduces the error and how it become a most accurate method. So although it having advantage that it reduces the error and most accurate method, at the same time it having the disadvantage is that it need large amount of sample. Why it need large amount of sample? Especially in case of the test solution, because in this experiment you need to take the DRC of the test along with the DRC of the standard. तो आपको टेस्ट का भी DRC लेना है और स्टैंडर्ड का भी DRC लेना है. Whereas in case of earlier experiment, that is interpolation bioassay or matching bioassay that we have studied, we have not taken the DRC of the test. But in this experiment, you will be taking DRC of the test as well as the standard. Secondly, every response, the response of the test and the 2 doses of standard that you are going to select, in those cases, you are repeating every dose for 3 times. So that is the reason why it is called as the 3-point bioassay. Since again you are repeating it for the 3 times, so it will consume more amount of sample. So overall, the most important disadvantage is that although it is most accurate, reduces the possibility of the error, but it need large amount of the sample. And when we are repeating this entire process, we need to give the number of doses of the drug, both the standard as well as the test, and as a result of that, it is the time consuming and the tedious method. So these are the 2 important disadvantages of this 3-point bioassay. That is, it need large amount of sample and it is more time consuming and tedious process as compared to your interpolation bioassay, matching bioassay and bracketing bioassay. Okay. So this is about the receptor binding site principle, advantages and disadvantages of this serotonin bioassay, and which is done through the 3-point method. Let's move on to the procedure. First, we'll see how the tissue it is isolated. So the isolation of the rat fundus strip, it is the basic thing that first we need to do. So when what you are doing, you will be sacrificing the rat which is fasted for overnight. So overnight fasted rat can be sacrificed so that there is no content in the GIT. Okay, so you can take overnight fasted rat and you can sacrifice that particular rat by using the process of the spinal cord dislocation. So how you are sacrificing? You are sacrificing by using the process of spinal cord dislocation, and once you sacrifice, you can open the abdominal cavity and isolate the stomach of that particular rat. So this is how it actually look. It is not basically the real image of the stomach of the live stomach, but it is just for your understanding. So this is simple image how stomach looks. Okay, so you will be isolating the stomach. Okay, and once you isolate this complete stomach from the rat, now I will tell you which part it is called as the fundus strip. So the stomach having two important part. One, it is the upper portion, then another it is the lower portion, and in between there is the middle portion of the stomach is present. So this uppermost portion of the stomach, it is called as the fundus. Okay, so now what you can do, you can cut this part of the stomach and you can remove this portion, and you can make the number of the strip. Now for example, this can be one strip you can make. Okay, then you can make the second strip, and you can isolate that, and you can keep that in a thyroid solution, because that is physiological salt solution that is needed to keep that tissue alive. Okay, so you can just cut there, you can make the strip and put that in the thyroid solution, and after that you have to mount that particular tissue in a tissue organ bag. So we'll see remaining procedure later on. Now first we'll see about the time cycle of the serotonin bioassay, because then we'll be proceeding with the TRC. So before that, you must remember what time cycle we follow in case of the serotonin bioassay. So we have seen in case of the serotonin bioassay, the contact time it is 30 seconds. Rest of the things are going to remain same. For example, in case of the baseline that we take without addition of the drug, it is the 30 seconds. So it is constant, you can see in case of all the experiment. So we have seen interpolation bioassay, we have studied matching bioassay. In all case of this bioassay, the baseline we are keeping same, that is 30 seconds. So before adding the drug, we are starting the drum and taking the response. Since we are not adding the drug, so it is simply giving the plain line. So there is horizontal plain line you will say, and that you measure for 30 seconds, that is called as the baseline. Then you are, after 30 seconds, you are adding the drug and you are taking the response just for 30 seconds. Since it is very fast contracting tissue, you can see the contact time it is reduced. So for 30 seconds is contact time, and once the 30 seconds is over, obviously you will get a response something like this. Okay, and then you can keep load down, that is the extra load you are keeping here. So that load you are keeping down. So the moment you keep the load down, what is going to happen, this is also going to come down. Okay, and you give the total 3 washing, so that drug can wash out from receptor binding site. So each washing it is of the 60 second. Since you are giving total 3 washing, so there will be total consumption of 180 seconds. That is the 3 minute. Okay, so whenever you are giving each washing, you can see this response is or this the reading it is coming down, and when it in the third washing, it may come to the level where you have started the experiment. So it will come to the baseline. Okay, so the moment it come to the baseline, again you can keep this load up, right? And you can keep this load up, and then, or you can keep this load here itself. Okay, any other part. So you don't keep here. Instead of that, you can keep that load here, so that there is no load now on the lever. Okay, and then you can record your baseline. So you can record the baseline again, and then you can give the second response and take the response for the 30 second, then giving the 3 washing, and this is how you are going to record the dose response curve of the serotonin. So washing of 60 seconds each, so total time cycle looking at this will be 240 seconds, or it is just for 4 minutes. So total time cycle it is reduced by the 30 second, that is 240 second, or that is the 4 minute. So this is about the time cycle of serotonin bioassay that we have to follow every time whenever we are taking the responses of the serotonin. Let's go ahead and now we'll see the detailed procedure of this experiment. So now we have seen how to isolate that. Now after isolation, we need to mount that tissue in on the tissue organ bar. So here we are going to mount that particular tissue, and we are going to tie that particular tissue on the lever, okay, by using the thread. There is another thread which is attached to the aeration tube, okay, and that can be that can be tied to the aeration tube, right? And aeration tube, it is connected to the aerator, from where you will the tissue will get the oxygen. Then you are filling the thyroid solution inside the this tissue organ bath, and once that is done, then you are keeping the extra load down, okay. So the moment extra load it is down, the tissue will start relaxing. So after relaxation of the tissue, you can record DRC of both the standard serotonin and test serotonin. So what is difference here? In case of the matching bioassay and interpolation bioassay, we have not taken the DRC of the standard, we have not taken the DRC of the test. We have only taken the DRC of the standard, okay. But in this experiment, we will be taking the DRC, that is dose response curve, of both standard serotonin and test serotonin solution. So this is the second step. So once this is done, third step it is, you need to select the two standard doses, and we call these standard doses as S1 and S2. So easy to remember, we need to select these standard doses in the ratio of 1:2. Now what do you mean by 1:2? Like for example, if you have selected S1 as the 0.1 ml, so if you select the 0.1 ml of the S1 as the standard, then S2 must be 1:2, means it must be multiplied by 2 of the S1, okay. So what will be the multiply by 2? So it become a 0.2. So if S1 is 0.1, then S2 must be 0.2. Likewise, if S1 is 0.2, then S2 must be 0.4, right? So whatever dose you select for the standard, so since it is 3-point bioassay, in this here, going ahead with the experiment, you need to select 2 dose of the standard and 1 dose of test, okay. So 2 dose of the standard and 1 dose of the test, so it is total 3 doses you are going to select. So 3-point bioassay, so you are selecting 3 doses, 2 of the standard and 1 of the test. And then you will be selecting 1 test dose that fall between the two S1 and S1, S1 and S2. So the test dose should be selected in such a way that their response height, it is bigger than S1 and smaller than S2, okay. So we'll see this in a detail when we are taking the dose response curve and going ahead with the experiment. And after this, once you are done with the selection of the test dose, then you need to repeat the doses of S1, S2 and T randomly in the sequence by using Latin square method. Now let's see what is Latin square method and how we are repeating these responses by using the Latin square method. So just before going ahead, we'll quickly revise what we have done till now. So first what we have taken the DRC of the standard, then we have taken the DRC of the test. After that, we have selected 2 dose of the standard in the ratio of 1:2. Then we have selected the test dose which lie between S1 and S2. And then third thing is that now these 3 doses that we have selected, now we have to take the response of these 3 doses in a random fashion by using Latin square method. Now what is Latin square method? That we'll see in this particular slide. So when you are doing the bioassay, you are doing this bioassay by using 3-point bioassay, then in such cases, each set of the S1, S2 and T, you have to repeat for 3 times. So you are going to repeat it for 3 times by just simply changing the sequence. And every time you see that the sequence that you have used in set 1, it should not be repeated in a set 2, or set 2 sequence should not be repeated in a set 3 and set 1. Okay, so let's see how it is possible. So first thing, we have selected 3 doses, 2 of the standard, that is S1 and S2, and 1 dose we have selected, that is of the test. So 3 doses we have selected. So maybe you can go ahead with this sequence in the first set. Like first you can give the dose of the standard, then you can give the dose of the standard 2, then you can give the dose of the test. Then in case of the set 2, you simply change the sequence. So here you are given S1, S2, T. Here you can give the dose in the sequence of S1, T and S2. So what you have done here, you have just changed the sequence, okay? And in the third set, you are giving the dose where you have given first T, that is the test dose, then you are given the standard 1, and then you are giving the dose of the standard 2. So in each of these set, you can see in none of the set there is a repetition of the sequence. So this sequence, it is completely different from S2 and S3. The S2 set 2, it is different from set 1 and set 3. Likewise, set 3, it is different from set 1 and set 2. Okay. So when you are just simply doing the randomization by changing the sequence, so this method it is called as Latin square method. It is well-known method in case of the clinical trial or in case of the selection of the dose of the drugs. Okay. So this is how we are selecting, or we are giving the different sequence randomly by using Latin square method. Now let's go ahead with the DRC of the serotonin and 3-point bioassay. So first important thing, let me clarify to you that since it is tedious experiment, it is the long experiment, so we are not following the tradition pattern of the equipotency and then up to the ceiling effect, but what we are doing here, we are just taking the 4 doses, we are just giving the 4 doses of the standard and 4 doses of the test, so that the experiment should not be the lengthy. So there is break in our traditional practice of taking the responses in this particular experiment. Okay. So let's see how to do this experiment. So first what we are doing, we are taking the DRC of the standard. So when you start with, so you have to give the first dose of the standard, and always we give first dose of the 0.1 ml, right? And then we'll give second dose of the 0.1 ml once again, so to ensure the equipotency. Then this is called as the equipotency, and you know that you have already studied this in different type of bioassay, because when same dose give the same height of the response, that concept it is called as the equipotency. Once it is done, then you can give the second dose, that is the 0.2 ml of the dose you can give. Now when you are given the 0.2 ml, you can see here there is increase in a response as compared to the 0.1 ml, and there is very good gradation between the 0.1 ml and the 0.2 ml. Okay. Then you can go ahead with the next dose of the standard, that is 0.4 ml, and the fourth dose you can give, that is of the 0.8 ml. Now everywhere you can see you are getting very good gradation, and each response of the standard it is different and having the very good gradation as compared to their earlier response. So once it is done, this dose response curve, it is called as the dose response curve of the standard serotonin. Okay, so you have taken the response with increase in a concentration. So we have done with the first step. Now what is the second step of the procedure? We have done with the DRC of the standard serotonin. Now we have to repeat the DRC of the test serotonin, because our principles say that in this experiment you are going to compare potency of the standard with the potency of the test. So to compare that, you have to take, once again you have to repeat the DRC. Okay, so we are now, after DRC of the standard is over, then what you are going to do, now you are going to start with the DRC of the test. So you have given the 0.1 ml of the test, then you can give the 0.2 ml dose of the test. So here also you can see as dose is increased, there is increase in the response. Then you can give 0.4 and you can give the 0.8 ml of the test dose. So what is the observation here? You can see as compared to the standard, every response of the test, it is smaller as compared to the standard. Okay, so this is called as the DRC of the test serotonin. Now what you can do, your third stage, it is the selection of the 2 standard doses in the ratio of 1:2 and 1 test dose that fall in between the S1 and S2. So we are done with the second step, that is the DRC of the test serotonin, it is done. Now third step, it is selection of the 2 doses of the standard. So since there is very good gradation between 0.1 and 0.2, we'll select the 0.1 and 0.2 as S1 and S2. So you can see here, in case of the S1, that is the 0.1 ml, we got the height of the 10 mm. In case of the S2, we got the height of the 15 mm. So the difference in between these two response, it is of the 5 mm. Since there is very good gradation is there between S1 and S2, we have selected S1 and S2 as a two doses of the standard for going ahead with the experiment. So selection of the two doses of standard it is done, that is S1 and S2. So while selecting these two doses, the most important criteria is that there must be significant difference between the height of the responses. Now suppose S1 and S2 just there is difference of 10, if this is of just 10 mm and if it is of just 11 mm, then don't select this. You can go ahead maybe with the 0.2 and 0.4 ml of the dose. But whatever you are selecting dose, that must be in the ratio of 1:2. Now you can see here these are in the ratio of 1:2, that because S1 you have selected it is 0.1 ml and S2 you have selected it is 0.2 ml. Okay, so it is just double of the 0.1 ml. So the selection of two doses of standard it is done. Now third thing is that you need to select the dose of the test which must lies in between S1 and S2. What it means, their response height it must be bigger than S1 and it must be the smaller than S2. Means 10 mm से बड़ा होना चाहिए and 15 mm से छोटा होना चाहिए. So let's see about in case of the DRC of the test. So when we see the height of the 0.1 mm, it is 7 mm. So we are not going to select because the height it is less than 10 mm. 0.2 mm, the height it coming to the 10 mm. So it is exactly same as the S1, but it is not bigger than S1. So again we are not selecting this dose. Then in case of 0.4 mm, the height it is coming to the 13 mm. Now here you can see this 13 mm height of the test, it is coming in between the 10 mm and 15 mm. So you are selecting this 13 mm, the response height or this particular dose as a test dose. Okay, so these dose you are selecting as a test dose. So 0.4 ml you have selected or in case of the test, and in case of the standard you have selected two doses, that is the 0.1 ml and second dose you have selected it is 0.2 ml for going ahead with Latin square method and the repetition of the experiment by using the random procedure of the Latin square. So what you have selected here, so in case of the N1 it is the dose of the standard 1 we have selected is the 0.1 ml. N2 it is the dose of the standard 2 we have selected 0.2 ml, and T, that is small t, it is the dose of the test that we have selected, it is the 0.4 ml. So now the selection of the two standard and test it is done. Now going ahead what we need to do, we need to follow particular sequence. So the first sequence we are going to follow it is we are giving the dose by the S1, S2 and T sequence. So let's give the dose of the S1. So we have given the dose of the S1. Okay, so S1 the dose was 0.1 ml we have given. Then you can give the dose of the S2, so you will get the response which will be the bigger than S1 obviously, right? And then after that you will be giving the dose of this test that you have selected, 0.4 ml test dena hai. So instead of the standard solution, now you are taking the solution from the beaker of the test sample, right? So standard, there are two beakers. So from beaker 1 there is presence of the standard solution. Okay, and the beaker 2 there is presence of the test solution. So you will be taking 0.4 ml from the test solution and you are giving the response. So you will get particular response. Okay, so now we are done with the first set, that is S1, S2 and T. Likewise, you can just change the sequence in case of set 2 and you are giving same doses. Like here what you have done, first you are giving the dose of the S1. So that is the S1 dose, how much it is at 0.1 ml. Then you are giving the dose of the test. So you are giving the dose of the test from the test beaker. Okay, that is the 0.4 ml. So and you will get a response. Then you will be giving the dose of the S2, that is S2 dose it is 0.2 ml. Okay, so now this is your second set is done. Then likewise you can repeat the response with the third set, that is the test, S2 and S1. So the test dose first you are giving, that is 0.4 ml. Then you are giving the dose of the S2, that is the 0.2 ml, and then you are giving the dose of the S1, that is 0.1 ml. So once this is done, you have repeated now each reading for a thrice. Now you can see here the S1, this is their first response, this is the S1, it is the second response, okay, and this is in case of the S1, this is the third response. Likewise, S2, this is the first response, this is the second response, and this is third response. Likewise, in case of the test, this is the first, this is second, and this is the third response of the test. So for every response, now you have to measure their height. Okay. So when you measure the height of every response, for example, S1, S2, T, maybe first time when you are taken the reading, you got the 10 mm. So this S1 here you may get 10 mm. Then when you have taken the second response of the S1, you got the reading of 11 mm. Right? And when you have taken the third response, you got the reading of the 11 mm. Okay. So what you can do now, you can take the mean of this. So 10 plus 11 divided by 3, it become a 10.66. Likewise, you can measure the response height in mm for the S2. So this is the first way you have taken, you got the height of the 14 mm. When you measure it for the second time, you got the height of 15 mm. And when you measure it for the third time, you got the height of the 15 mm. So you can take now average, that is coming to the 14.66. Likewise, in similar way, you can take the average of the response height of the test. So now you have the mean value for S1, S2 and T. Now what happened in case of the matching and interpolation bioassay? You are not repeating each test dose for 3 times. So it could be possible that whatever response that drug it is giving, suppose this response, the test dose that you have selected, if it is giving, since you are not repeating it with the change in the sequence, it's quite possible that whatever height you received, it can be the error, or it may be the some erroneous reading you are getting. Right? And since you are not repeating, because limitation is that in case of matching bioassay, you have very less amount of sample. Since very less sample is available, so you cannot repeat the reading for a thrice. You cannot take the DRC for selection of the standard and the test. Also, you cannot repeat the DRC of the test, because your limitation is that you have very less amount of the sample. But that you are reducing here, that error can be minimized, because here you are taking the average height. Okay. So you can take the average height, and whatever the reading you get, you can simply put that in the formula for calculation of unknown concentration by using 3-point bioassay. Let's see what is the formula for this. The Ct is equal to N1 by T multiply by antilog of T minus S1 divided by S2 minus S1 multiply by log of N2 minus N1, then complete bracket. Okay, so that you will get, it must be multiply by concentration of the standard. Okay, so this complete bracket, it must be multiply by concentration of the standard. So isko multiply aapko karna hai, and that is going to multiply by N1 by T. So one by one you can solve. First you can calculate N1 by T, then that you can multiply by antilog of this complete bracket, and that can be multiplied by the CS. Okay, so what is the Ct? Ct, it is the concentration of the test. N1 and N2, these are the dose in ml of S1 and S2. So how much is the dose of the S1 and S2? That is the 0.1 and 0.2 ml. Okay, so it is 0.1 and 0.2 ml. Then T, it is the dose in ml of the test. So how much is test dose you have selected? It is the 0.4 ml. So it is written over in this particular table. Then what is S1? S1, it is the average response height of the low dose of the standard. So low dose of the standard is the 0.1 ml. Their average response height is coming to 10.66. Then S2, it is average response height of the high dose of the standard. So high dose of standard you have selected is the 0.2 ml, and their average height is coming to 14.66. Then T, it is average response of height of the test dose selected, that is the T, so it is coming to 12.66. And CS, it is the concentration of standard that we have seen in case of experimental condition. It is 10 microgram per ml. So that will be, this complete bracket will be multiplied by the 10, that is concentration of the standard. And once you complete this, once you calculate this, then you will get particular concentration. That will be the concentration of the test in microgram per ml. So now that you can calculate by using 3-point bioassay. So what are the learning outcome of this experiment? So most important learning outcome that we have seen in this experiment is for serotonin bioassay, we have used the fundus strip, because the fundus, it is the part of the GI tract where serotonergic receptor are present, right? So that is the reason why we have selected the rat fundus preparation. Second important thing is that a contact time, it is less because it is very fast contracting tissue. Third thing we have studied, the method it is different, that is the 3-point bioassay we are using, where we are taking the average height, so it reduces the possibility of the error and it gives the most accurate result. So most accurately you can calculate the concentration of the test. Okay, so this is the third important thing about this experiment, but at the same time it having disadvantages. You can see you have taken number of the responses of the test as well as the standard. Since you have taken the many responses of the test and the standard, it is very time consuming method and it is the tedious method. Secondly, it also need more amount of the test sample because you have to take the DRC of the test, and for each test sample you have repeated reading for a thrice. So it consume more amount of the sample. So this is all about the serotonin or DRC or the study of unknown determination of unknown concentration of the serotonin by using 3-point bioassay. So this is the disclaimer. So all the data used in an experiment is just for demo purpose only. It does not have any relation to the real data collected from study of DRC of the serotonin. Also, all images used in this session are used under Creative Commons license for study purpose only. The source of image are cited wherever deemed to be necessary. So thanks for watching my session. For more such learning, subscribe to my channel. And if you like my session, then do remember to give me a thumbs up.